guys, welcome back to your YouTube channel. This is our last lesson. Goodbye.
It's the last lesson. Welcome to the beginning of the end. Today is the last lesson. This is your introduction to derivatives. Thank you for taking your earbuds out and having your laptops closed. This is your intro to derivatives. We will be talking about finding slopes of equations of tangent lines. Tangent lines. We'll find the derivatives of functions, average rate, instantaneous rate of change, and instantaneous velocity. We'll try to get through the whole thing. And maybe we finish today, and if we don't, then we finish tomorrow. It's not a big deal. It's not in a hurry. Objective is that you have solid beginning foundations. I did have questions about what are we doing after finals, senior finals? We're doing more calculus. But it will not be Greek book calculus. So it'll just be concepts, introduction type stuff. We'll just chat about it.
Sounds good to me.
There'll be some chat about it. I'm not going to assign you homework on it. So I won't expect any of that. Okay? And it won't be very much because it'll be like what? 1 day? Literally, it'll be just 1 day.
Wait.
Yeah, because senior finals are Thursday, right?
Next Thursday?
Yeah, and then
Wait, hold on, wait.
no, on that Thursday after senior finals, it'll only be one Friday that's open.
Yeah.
Because that Monday I will not be here. No, actually I'll be here for you guys.
What are we gonna do?
Yeah, I'll probably be here for you guys.
We have like
Because usually I'm out on the field on Monday with seniors, and then Tuesday as well. But I think I'll be back for you guys with and you guys better be here with some ice cream.
Well, that's it.
With some EGs. No, I
it
don't.
doesn't work.
I do have shears though. Would you like some shears? What are you serious?
Frosted Flakes cereal. Oh, hey, thank you. Frosted Flakes.
All right, here we go. So, I think that I've talked or mentioned this before. Thank you. Take your earbuds out, please. We've talked about this before
Oh yeah.
a little bit, and we've talked about average rate of change. Average rate of change. When we're talking about average rate of change, let's say I do have some graph that behaves kind of like this, and I want to know what the average rate of change between A and B is, right? And of course, A has some coordinate x, comma y. We'll call it x sub 1. Actually, we won't. Let's call it x sub 2, y sub 2, and then we got some other point over here, which is called x sub 1, comma y sub 1. And if we wanted to find the average rate, we'd be looking for a secant line because it crosses 2 points on that curve. And the way we would go about that is by taking y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Correct? That is the slope formula, and we're looking for the formula of that line that crosses through those 2 points.
Why should we do that?
Huh?
That's different than usual.
Yeah.
It's like
I changed it to calligraphy. You didn't remember like, what was it, 2-3 days ago?
Yeah.
I like the calligraphy version better. So, you guys remember all this good stuff? Okay? Don't change it. I shall not.
Remember this stuff, but I just want to finish writing. Okay.
Are we good here?
Yes, sir.
Anybody still writing? No? Alright, so moving on.
No.
I don't know if I've said this before formally, But when we're trying to do this, what we're really doing is we're looking for, and you're going to hear this in calculus a lot, delta y, delta x. Delta is Greek letter for D. But in mathematics, we use it a lot to represent change. So this is the change in y or the change in x. And of course, change, to find the change or difference, is a subtraction problem, right? So as you can see from the top, it's the difference, or it's the change in y over the change in x. Okay? This is average rate of change. Average rate of change is nice sometimes when we don't have a lot of movement, right? If we're kind of continuous and we're kind of smooth. But we know that the fact is that when we travel, we don't always remain at constant speed. So I mean, sometimes we do hit that auto, what is it, cruise control. Hit that cruise control, and maybe you are doing a continuous, thank you very much, continuous speed of some. But at some point, you probably brake and speed up and slow down.
Is it for me?
Okay. What we're trying to do, so let's do this. Let's assign some values here real quick, just because it's kind of nicer to see some numbers assigned. So what's a legit value for this? 2, 1. 2. I heard 2, 1 first, so I'm gonna go with 2, 1. Ernie, you want to give me one for this guy?
12, 10.
12, 10 sounds good to me. So, average rate of change. That means I'm going to take that value, 10, and then take away 1. And then I'm going to take 12 and take away 2, correct? That's going to give me 9 over 10. So my average rate of change would be 9 tenths. Right?
Yeah.
Simple enough. All these ideas make sense to you, right? Okay. So we call this a secant line. What we're trying to do is we're trying to move from a secant line to what's called the tangent line. And if you remember from your geometry, tangent lines touch at exactly 1 point. And the reason that we're trying to find the equation of a tangent line is because that would give us instant rate of change. Here's what I mean. And I think I've said it, like I said, I've said it before. Let me go ahead and redraw these with some blue. Okay? Let's say that I wanted to know, I'll keep the blue. I wanted to, ooh, what did I do? This is nice. Whoa! Did this break? Okay, that was weird. So let's say I wanted to know how fast I was going at this point, okay? So what I could do, instead of having my 2 points out there, is that I could move them a little bit closer to each other. Do you guys see how that would make another line that would be a little bit more representative, right, of the true slope there between those 2 points? If I move them closer together still, would my new line be a better representation of that rate of change?
Yes.
It kind of would, wouldn't it? And what I would want to do is I want to get those points so close to each other, the limit, so close to each other that they're in fact one and the same point. Right? So now it's not an average rate of change. Now it's an instant rate of change. So what I would want, because I only have 1 point now, I have what's called the tangent line. It's only going to touch at 1 point. And the equation of that line would technically be able to produce for me the instant rate of change. Because now there's no distance between my 2 points, right? But that causes some issues. Can someone give me a legit point for here?
5-1.
What is it?
5-4.
5-4? So, remember, this is my y2, x2, comma y2, as well as my y1, comma x, or x1, comma y1. So if I was going to find my rate of change using this formula, I would be doing 4 minus 4 over 5 minus 5, which would give me 0 over 0.
4 minus 1.
Now, that should not be surprising because obviously we're using the same point, right? We're taking away from itself. And if I did this with any points, like let's say that's not where I wanted it, maybe I said, oh, it just kind of works out that way. Maybe I want to find the average rate of, or the instant rate of change here. I would have one coordinate, which means I would be subtracting that coordinate from itself. Right?
Yes.
Which would ruin everything. And you would always end up getting 0 over 0. So, a fix for that is simply a notation issue. It's simply going to be a notation thing. Okay? We're still going to take that same idea of y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So many subs. And what we're going to do, let's see here, let me draw this curve again around her, is to think about it differently. So let's put a coordinate here. We'll call that A. Okay, and we'll put another point over here. And we're going to move over some distance, we'll call it H. Okay? Is everyone okay with that?
Yes.
Okay. So if I have A, do you guys remember what we used to call the y value now when we're with functions? Instead of y, we called it f of x, don't we? So the coordinate here would produce f of A, would it not? So if I have A, the y equivalent would be f of A. And if I travel some distance over here to H, what would my equivalent y be? It would be f of A plus H. Okay, because the distance from here to here is H. Okay, does that make sense to you guys? Okay, so that distance between A and this is H. So now we have f of A, we have f of A plus H. Simple enough?
So what would f of h be?
F of H would be whatever y value it is once we plug this piece in here. Because the distance from here to here is how much?
A.
The distance from here to here is A. The distance from here to here is H. Okay? Are we good?
Yes.
Because it obviously can't be the same number, right?
Yeah.
We have a different number there. Alright, so let's take that idea now. And let's do it, yo. Let's do it, yo. That's my sub 2 stuff, isn't it? And this would be my sub 1 stuff? Because it's always the bigger one minus the smaller one? Do you agree with that? Cool beans. So that means we're going to have f of A plus H minus f of A over H minus A. Yeah, we did.
I don't like those.
I think I
Oh. This is not correct. This would end up being, what would this end up being? If this distance is H and this is A plus H, correct? So this should be not just H, it should be H plus A minus A. Sorry about that. Yeah, because this, yeah, and you're going to see that the A's do cancel out, right? So we ultimately have f of A plus H minus f of A over H. Cool? So, do you see how it's still this idea? We're just thinking about it differently now? That fixes our problem. Go ahead. Well, yeah, it doesn't matter what number it is. We don't know what number it is. So this distance here is A, correct? The distance from here to here is H. So, in fact, if I want to give this a coordinate, the x value would have to be A plus H, comma, f of A plus H. Sorry, little h. Okay? And that's the coordinates that we're taking and we're plugging into our change in y over change in x formula. That looks different. Did that answer your question? Thank you. Good question, because I was not clear on that. All right, we good so far? So, questions on this formula that I just came up with, or that we just came up with? No? That is called the slope of the tangent line. That is the formula. That is the formula for the slope of the tangent line.
With the limit in it too?
No. It's just the slope of the tangent line. The limit is calculated differently, isn't it? We take a look at the actual function.
I'm just gonna write down.
Yes. The limit is calculated by taking a look at what we're approaching, right? The tangent line would be the equation that satisfies that, which would be what touches there. So that equation has many multiple points, so you can't call that the limit, unless you know what specific point you're trying to plug in.
But in the equation, the one with the limit in it, the one with the limit in it is the thing that you find the slope of the tangent line.
Say that one more time.
Okay.
Yeah, so I see what you're saying.
The slope of
Yeah, so the slope of the tangent line, it says m, which we call the slope of the tangent line. As the limit approaches, where h approaches 0, it's going to give you that equation. I want you, I think this is the part that Hank's been waiting for a long time, is that technically what's going to happen to h, or all of our constants, is that they're going to just go 5. Because what are we approaching for all of our constants? 0. And if h is 0, then bye-bye. They go away.
the limit doesn't exist.
No, not necessarily, because what we're after is an equation of a line in this case. We're not looking for a limit now. We're looking for the equation that is tangent to that, okay? Don't confuse the two. They're both important ideas. They're both very important ideas.
It's H.
No, it's as h approaches, it's a limit. As h, I need like a little arrow tool. How does Rosal draw his arrows? Does his look better than mine?
Like a normal arrow?
Yeah.
I don't know.
I don't know.
Will that work?
Yeah,
Is that better? No, that just takes too much time.
Yeah, I like the colored one too.
Ah. You know what I need? You know what I'm gonna do? I'm gonna make me a button that has that arrow stamp.
Is that not one right there?
No, that's just my pointer.
Just draw
I
a
thought the
thick
line segment
arrow.
was.
Yeah, but it won't do.
Oh,
I know.
well, there's arrows right
Oh,
there.
there's an arrow one.
Oh!
Oh, I could do that.
Yeah. Now you can't erase it.
But you know what? At least you won't clown on my arrow.
It looks a little bit
How
slanted.
clowned on your circles at the beginning of the year?
Is that a,
You guys are horrible people.
Is that an O or a
You
zero?
were bad for our math self-esteem.
is that a subtraction sign?
What's up?
Have a map.
Yes, I just did it bigger. Oh, sorry. Thank you. Good looking out. This should be minus. It's the difference, right? It's a change in y over the change in x. Change in y over the change in x. Horrible, horrible deltas. But you get it. Shut up, man.
I told my mom about it.
Just love the wall. Are you the best in how
Oh, so I went to the library. Librarian said she didn't really have the one that you're looking for. I know what you're looking for, like the wire one.
Yeah.
Yeah. And so I went into the office and knocked at Mr. Anderson's door for a little while. He's not there. Then I go to Zona and she's not there. I sit there for like 10 minutes. They're probably at lunch, so.
Oh, I didn't think about that.
So I'll try again at the end of the period.
All right, ask questions, please. Ask me some questions. Looking for at least 2 right now.
So
Ernie.
M is the slope.
M is slope, that's what it's always been. So the slope of the tangent line.
So is H gonna always approach 0?
Yes.
Yeah, we'll always approach 0 because what we want to do is we want to get rid of some of the stuff that's not needed, which kind of sucks because later on you're going to want that stuff back. In the integration part, where you're going
Oh,
to reverse.
Yeah.
Which calls for unfunness. But anyways, yeah, we're always going to go towards 0.
Integrals are stupid. Derivatives are fun.
Derivatives are fun, integrals are kind of tougher. Because, here, let's do something real quick, okay? Alright, I had one question. Anybody else got a question? I need one more. Go ahead. So let's take a look at that. You guys ready? So, there was more question. Yay! More than one. 1, 2.
So you're not looking for the limit of it, even though it has like the limit.
We're not looking for limits. We're looking for the equation of the line that's tangent at that point. So, let me repeat this. What we are after... Oh, these are my arrows. They don't delete. The same way. So, here's one thing. So, let's do this. Here is some curve, right? And if I want to know the limit, I'm looking at what, I don't know, let's call it A. As I'm approaching A, I'm looking for some Y value I'm getting close to, correct? That's the limit. What we're after now is going to be the, damn, that's bad. That's horrible. Let me try this here real quick.
It's the touch and not cross.
Yeah, a little bit better. So what I'm trying to find now
It's not a
is the
line.
equation of this line that's tangent and touches only at that specific point.
That's
So,
right.
so the point that they're touching would be the derivative, would be the limit, but the derivative is that equation of the line that touches at that point. And that's what we're after right now. Okay? Tag team, go. You are next. Here we go. So let's have you walk around, and we can help some of these people out.
Okay.
I don't want you to do this yet. I don't want you to do the point. I don't want you to do the point yet. I want you to just first find the derivative of this.
Can I teach them the easy way?
No. I know. Please don't. No.
Because I didn't learn this way. I learned
No.
You make math hard.
Okay. No. No, because you're going to take that away from Mr. Rosen.
Okay, but what about us that don't have this road?
I can tell you on the DL later.
Can we go outside?
Wait, no, you're gonna tell me.
This is not hard. You should not stress on it.
Right now.
It's not hard, so you should not stress on it.
It's not hard.
This is the prime point.
It's not hard. It's just long. It just takes time.
Watering 6 times since I've been in this
Okay. Did you walk through an example yet? You walk through it? You walk through an example yet? Like this one.
Yeah, we'll go through that right now.
Because like that's what helped me learn. Alright.
Here's what you're going to need. You're going to need two things. You're going to need f of x, which they call f of a, and you're going to need f of x plus h. Okay? So stop and think about this for a second before we continue. This doesn't change because it's the same, correct? But now I'm going to change my x for x plus h. So I'm going to write both versions first. Can I do that? So this is x squared minus x. Are we good?
Yes.
What goes in my parentheses?
4.
I told you not to worry about this yet.
Oh.
Don't do that yet. Okay? So this is going to become x plus h. This becomes x plus h. Okay? And now I'm just going to clean it up. This becomes,
Oh, is this like the s of 1 equals s of k plus 1?
Kinda.
You know what I'm talking about?
no. But I'm going to continue. Yes! Oh, yeah, that's what we refer to in
Is that
derivative.
what this is?
That's way back then. Yeah, exactly. Let's clean this up. This is going to give me x squared plus 2xh plus h minus x plus h.
Wait. Plus H.
Oh, sorry, minus h. Because I got to distribute that negative, right?
Should be H squared.
Thank you. Thank you. Here we go. You guys good?
Okay.
Distributed.
Yes, we are recording. So let me do this. I'm going to change this color right here, and I'm going to show you where that part came from. So all I did with the x plus h squared was to expand it, FOIL it, whatever you want to call that. And then the blue part is simply the distribution of the negative. Once we clean this up, let me get back to my red. We're going to get x squared plus 2x, right? Sorry, 2xh plus, hold on, I'm missing next. Well, they're all the same. There's nothing to combine.
Yeah, you can't combine.
Can't combine anything, so leave it alone. Can't combine anything, leave it alone. Bad, Mr. Munoz. We're good? I'll just wait here. Not yet. Well, we're still going. We're
This
still
is the
going.
start of it.
I know what is being asked right now. I gotta breathe through your nose.
Well, all we're doing right now is we're going to try to get the equation of a line that's tangent at a specific point for this function.
But what does that have to do with the equation? Oh!
F of x plus h, f of x. We're going to need those two to put in there.
I just figured it
Okay?
out.
All right. So, we're good? I'll continue? Let's continue. So, all of this all of this, beautiful,
Who's on the top?
is technically my f of x plus h, or the f of a plus h as they called it. So that's going to go first. So I've got x squared plus 2xh plus h squared minus x minus h. Then from that I'm going to take away my original function, right, which is f of a, or what we're calling f of x, which is x squared minus x.
All over each.
All of that over h.
And that's
Does this just have to be equation or is that the whole equation?
Sorry, say it one more time.
Is that just like half the equation?
What is half the equation? Greg.
Didn't you have the, is that all you need or do you need to do the limit part too?
No, we're not doing limits.
No, I know on the other equation it says,
We're not
We're not looking for no. Don't worry about that. Right now, what we're doing is we're finding the equation of a line that's tangent at some specific point. So right now, what we're doing is we're gonna find a generic one. Okay. Right now, we're finding a generic tangent line. Yeah. AKA the derivative. Okay. I was gonna say the first one, but then I can already hear Genevieve saying, "There's a second."
the first derivative.
And there is.
And then you got the jerk.
That's fun stuff. Let's clean this up.
Yo.
Let's clean this up. Wait a minute. Was this minus?
Yes.
Okay, just double checking. Ah, what did I do? I hate when it does that. Get over here.
Why is this in there? There we go.
Okay. You guys ready?
Yo.
X squared minus x squared. Gone.
Zip. Nada.
So I've got 2xh plus h squared negative x. Negative makes this a positive x, doesn't it? Gone. Minus h all over h.
Factor at the.
Going up here, what do they all have in common? They all have h in common. Did you already do this?
Yeah, I did.
So I have h, that's going to leave me with 2x plus h
No. Oh yeah.
Yeah.
Hey, my bad.
minus 1.
Yeah.
And that's all over h.
Divide.
H over h becomes
Kill it.
1. So now I have 2x minus 1 plus h. This, my friends, is the equation of the tangent line.
Yo.
Of a tangent line.
Can you make it like a full, like can you put all the answers on one page so I can take a picture?
Okay, like that? Okay, I'll pause for a little bit, but you guys copy that down.
I want a picture.
Where'd you get the red one?
Or blood red.
I never understood it, but I don't.
Yeah, cool.
I didn't hear when I found
Shared it.
It's weird.
This
This hurt.
gives you hair up. Me on graduation.
Dang. Should have checked the blood. That's not like strip bullet.
So,
And then h approaches 0. So it's 0.
okay, so that's okay. I'm getting the honors people. Now we're like everybody's graduating with honors, right? 3.5. What do we get? Our medals?
Take a little one.
When do they give us this stuff?
Academic.
It's not even what I'm going about.
here's what we've done. We have found what's called the first derivative. Okay. This bad boy will produce for me any equation of any slope at a tangent line. Okay. The problem that we just did wanted us to figure out what it was going to be when x is 4. What I did, there it is. So here's what I've done, just to make this a little bit clearer for you. Unfreeze. Okay. I've gone ahead and graphed it. Here's what the graph looks like. It's just a parabola, shouldn't be surprised. It's x squared. Okay. I can have many different tangent lines at different points, right? Depending on what x value I have. And all of those would have their own what? Slope. 1, 2, 3, 4. I'm looking, I don't even know if I can make it there. I'm looking for the slope of the line that hits where x is 4. Okay? So guess what I need to do now? I'm simply going to put in a 4 of x. Sorry, x as a 4. Question though, what is h?
Big question.
What is our limit going to always? It's going to 0. So that means that our equation is 2x minus 1. So once I put my 4 in here, 2 times 4 is 8 minus 1 is. So the slope of the line that is tangent here is 7.
Wow.
Wait a minute, so H is always going to be 0?
It's going to go to 0.
Yeah, you might want to write out the limit thing.
Wait, why?
It's always going to go to
why
0.
is H 0?
We're always going to have to go to 0 because we're going to get rid of that because we just want the equation of that line.
So basically, we just.
Where they
Why
go?
did we add the H as the equation first?
Well, the h goes in there because remember what we had to do to make the formula work for us? Remember what I said? In order for the change in y, change in x thing to work for us, we can't use x and y anymore. So what we did is we defined some distances. We defined this first distance to be a distance of a, excuse me, box, and the next distance to be a distance of
You
h.
said boss.
Box. Okay?
Sorry, boss.
So it doesn't have to be h. If I would have defined this distance as a p, then that would have been a plus p. Okay? So all we did was define this distance so that we can find the difference between them mathematically. So h is something that's kind of built in there. We don't really want that thing, do we? So we always make it go to 0 because if h is 0, then by h, you're gone. And I can truly get what I want, which is simply the equation of the first derivative, which will produce for me any slope that I want.
Are we ever going to need it in there? Like, are we ever going to use it?
Maybe the second half. What do we
yeah.
call it? What do they change it though? They don't call it h anymore, they call it c.
Yeah,
So
it's a constant.
don't worry about it. Don't worry about it right now. You're in the intro stuff.
Okay.
As long as this
Don't worry
makes
about
sense right now, you're okay.
Differential calculus, not differential calculus, not.
You guys good? Are you ready to try this?
Yes.
No.
Let's go. Woo.
Wait.
Okay, so ask me 2 questions then. Ask me 2 questions.
What's the
You have one? Go.
Is f of x plus h always going to be x plus h squared minus x plus h?
No, it depends on your function. Because in this case, my original function was x squared and then x, right? That's why this got squared and this did not.
Replace each x with the x plus a.
Right. Here, think about function notation. If this was f of 4, what would go inside the parentheses? 4s. But in this case, we're not putting 4 in there. We're actually putting x plus h in there. That's why those became x plus h. Good question. And yes, it will almost always be x plus h. Except when you kind of first start, like once you get this mastered, they'll mess around with some weird things in there. They might give you x plus h plus p or something.
It's going to be in tonight's homework.
You had a question? Go ahead. I can't even hear you, so try that again. In a real life situation. No, it wasn't. I couldn't hear you very well.
In a real life situation, why would you need to find the derivative?
Okay, so that's a good question. We do something called rocket science, right? And we put rockets. I think that's probably the biggest example, right? We put rockets in the sky, don't we, in the moon and in our orbits and stuff. And there's a couple things that go on when they're first testing rockets. I think that they have their initial liftoff, right? And then it kind of starts losing some oomph, right? And then what do we have at that point? Another second tank of fuel, brrrr, shooting off. We want to be able to calculate how fast it's moving at that specific point, and maybe when it is that we need to have the next fuel burst to be able to get it out into outer space. So all these specific points are important for us. We have to be able to calculate those, and that's what the derivative does for us. It lets me figure out how fast I'm really moving at this point, how fast I'm moving here, because what I don't want, ever, is for my rocket to shoot up, lose some height, and then go back up.
Right.
Does that make sense? And then I'm wasting fuel. So I want to make sure that I can get at that peak point and then shoot off again.
My best explanation is the relationship between acceleration, velocity, and position.
Yeah, and they'll get to that. You guys will get to that. So,
That's the best way I
so
can
Hank
explain
was talking about one thing. Well, go ahead and repeat that further so you can hear that.
Well, it's the relationship between acceleration, velocity, and position.
Okay, and each one of those is a different derivative itself. So, it's your first derivative is your
Position. What? First derivative is velocity.
second derivative is,
acceleration.
and then third derivative is
Whatever.
whatever it was. And you learn that in calculus. I'm
Meters
too
per
dusty
second
to go back
cubed.
to that and remember all the stuff. But there's some fun things going on because it does kind of go in little pieces, kind of like in computer science. What do we have? We have the megabyte, then we have the byte, and then we have eventually we get so the bits get smaller until you're down to a nibble.
Oh yeah.
So it's kind of funny that way too, and it kind of gets there at points
The
when you get
jerk.
to the jerk. It's just so here you go. Go and try it out. Leave the point for the end, please. Find the equation of the derivative. Find the derivative first, and then calculate that. I think that's the easiest way to do it. A lot of teachers will have you do it along with the point, and it just confuses
Oh,
the
boy.
junk out of me.
What even is it?
Find the derivative.
Wait.
Find the derivative first.
Start us off.
Okay, I'll start you off.
Wait.
What do you need? You need f of x, and you need f of x plus h. This is just the square root of x. This will be the square root of x plus h. And there you go.
Oh.
All x's become x plus h.
I'm trying to remember what the derivative is. Oh.
Well, you'd have to go half, then you'd
Yeah.
go,
It's
Kick it to the
1
front,
over
so-
2 squared.
so it'd be 1 over 2x to the negative
To the negative 1/2, so 1 over 2.
So which
square
would
root of
become
x, which would be
1 over 2x to the second? Because you gotta flip that.
well, you can multiply the whole thing by x
So it
over
would
2
be
times x
power
over 2.
over root. No, so it would be 1. No, I need to write it down. I'm trying to visualize it. Power over root. So it goes down. So it's going to be 1 over 2 square root of x. 1 over 1/2.
Yeah, 1 over 2 square root
1
of
over
x.
2
But
square
then
root of x. Yeah.
you can make it where the square root's in the numerator.
But that's over eight.
Square root of x over square root of x. So it's now square root of x over 2x.
Is it?
Yeah. Oh no. Only they knew the power rule.
Does that say what?
1 comma 1. Wait, so then, oh, I forgot what I had. I forgot what I wrote down. So if I plug in 1, I get 1.
What song is that that was?
Our, Chill Bill.
Chill Bill.
Chill Bill. I didn't know what it was called either. Someone told me. I was like, oh, it's a Kill Bill song. It's called Chill Bill.
Well, it is from Kill Bill.
Right.
The
But that's
guy,
what I was called.
the guy that made it popular
Called
it Chill Bill
Yeah.
and rapped on the beat.
Rapped on the beat.
Yeah, he did.
Well, American Horror Story, that was on there too.
What?
That was in American Horror Story too. He was like, what's his name?
Oh, yeah?
Yeah, he had all the face paint on. He's like walking through, and he was like, hiding in the back of
what you're talking about, yeah.
How did the lyrics go?
There was no lyrics, I think. Was
Says
it?
you wanna go. Yeah.
All I remember is
That's the rap version. There wasn't any in Kill Bill.
Is that the trap version?
It is. Rob Stone to the bone. Everyone's gonna crush you. Used to sing about style. Dang, that's sad.
No, it's all right. Fine. You guys good? You guys nice and stuck yet?
Yes.
Sir. Alright, here we go. Here we go. So we should have gotten to the point where we got the square root of x plus h, right? Minus the square root of x, and that's all over h. Yeah? At this point, you're like, what? Oh my god, how am I supposed to get rid of this h? And we could square it. Like, someone's idea was to square it, right? But what's the golden rule say? If you square one side, you gotta do to the other. So now you're changing the other side, and the other side really isn't anything. It's just f of x. You can't square f of x. Do you guys remember rationalizing the denominator?
Yes.
So what we're gonna do.
I'm gonna rationalize it.
Okay, here you go. Hold on. Go ahead.
Oh, I said, how does that apply? Because there's just an H down there.
I know. Well, we're not going to rationalize the denominator. We're going to rationalize the numerator.
Wow.
So by doing that, check this out. That means I'm going to have to multiply this by its conjugate, square root of x plus h, minus, sorry, not minus, plus x. And I'm going to do it to the bottom as well, correct?
Oh, I'm stupid. I didn't even think about that.
Now, can someone tell me why that's not going to be an issue?
What?
Someone
Why
take
that's
a look at
gonna be an
that.
issue?
Because all I've done is added more square roots, right?
Yeah.
Why is that not going to be an issue? Hold on. Think about that for a second. Why is it not going to be an issue with this problem?
I don't know, square root times the square root is gonna get rid of the square root.
In the numerator, but what about the denominator?
Well, now you can.
Let's use this universal sign for I have a comment.
H is gonna be a 0.
Nice and loud?
That was really loud. It's gonna be a 0. So
If
it's
h is
gonna be
0, remember h is going to 0?
Yeah.
What's 0 times anything?
A 0.
It's going to go away.
But that's not good.
That's not good, but we'll see right now.
I'm struggling.
That's a little tough one on here.
It's just so much easier to do the power roll.
I know it is.
It's so much.
You would have been there like
I had it in like 2 seconds. So
30
I was like,
seconds?
yeah.
not even that.
So.
Well, let's see it. Let's get to it first. Let's get through it.
Should be.
So let's get through this. This is gonna give me x plus h on top, right?
Yeah.
Minus x over h. What is it?
Radical
H.
x plus h plus h radical x.
Okay. It's h square root of x
You're
plus
losing me.
h plus h square root of x.
Yeah. Yeah, that's what we're being. Yeah, radical h.
Yeah, but I'm gonna factor that anyway because I want to cancel my h's.
Yeah.
So we have this. Is that correct?
I don't know.
That doesn't feel right.
Well,
We have
the
x plus
middle,
h
the
minus.
middle one goes away, so then you'd have
Right,
yeah,
the
minus
conjugates.
x.
This will give me x over, oh sorry, h. Ah, here we go. X plus h plus the square root of x. The h's are gonna go away, and I'm gonna get
Still
0 up top.
Wait, okay, so.
Whoa, hold on.
I got stuck here. I thought it was gonna be a good idea.
Wait, I thought you could
Hold
just,
on.
like, wait, if you're multiplying.
You're taking away h from all three of those, though. Right? Oh well.
No, wait a minute. I can't cancel out h, can I? Hold on, hold on, hold on, hold on, hold on, hold on, hold on. Let's go back. Let's go back. Let's go back. Let's go back.
Well, I'm showing you.
F of x minus square root of x.
And if you have x plus h minus x, don't you just have h on top?
Oh, it's not 0. It's not 0. X does cancel out x, correct?
Yeah.
And you get h. And see, here's where I have an issue where we tell everybody things cancel out. They don't cancel out. What do they make? They make 1. So when my h's cancel out, what's really left on top? 1.
Ah, yeah. Okay.
Okay? So now I can leave my 1 up there. I can plug in the value that they wanted, which was a 1, correct? So if this is 0, what's the square root of 1? Holy junk, that's a 0. Now I gotta take another step back again.
Well, no.
Okay, wait.
No, because then it's minus the square root of 0, which is 0. So
No,
it's
because that's
1
h.
over 1.
That's x, sorry, not an h.
I thought we were adding on the bottom.
But you don't have an
Ah, there you go, thank you. Good looking out. It's plus, plus, plus. This is a 1. 1 plus 1 is, therefore we're gonna get 1/2. Oh my god!
That's the right answer.
Oh my god! Okay, so let me go back, okay? Because that was a lot and it threw me for a loop. Are we good here?
Yes.
Are we good with the ratios in the numerator? Okay. So in the numerator, we're going to get x plus h, and then we're going to get minus x for the second part, correct?
This one's.
We're good? Cool. So now I have h times this x plus h business plus the square root of x. Thank you. You found that one really good. Now up top, x minus x is 0. So I have h over h times square root of x plus h plus the square root of x, right? What's h over h? 1. So here's what I've got now. I've got 1 over the square root of x plus h plus the square root of x. We're looking for the tangent line where x is 1.
1.
So x is 1. What's h? 0. What's the square root of 1? 1. What's the square root of 1? What's 1 plus 1? So there we go. So that means, let me go back to here now. That means that when x is 1, there's a line that is tangent right there. Guess what its slope is going to be? 1/2. Oh, that's not bad. Check it out. Up 1 over 2.
Hey.
Hey!
Okay.
Okay? Now,
Yeah.
Yes. ooh, that one got me.
That one got me too.
But the sign change, it was a sign change that he got. That one thrown off.
Yeah.
I made a
It's
sign
like,
change.
that's number 1.
Okay,
That's not
so,
right.
see how on the top.
Questions? I got 2 questions on the floor. Go.
You're rationalizing the numerator, right?
Right.
So you have x, or the square root of x plus h times square root of x plus h, yeah? So like, what?
The only reason why I did that is because if I didn't rationalize it, what does h go to?
Well, I know that.
Okay.
My question is, like, why wouldn't you just have, why wouldn't it just have been like this right here?
Because we used the conjugate. So if you did this, you would get that. No, you wouldn't. You would get x plus h squared, and these undo each other.
Oh, okay. Yeah.
Same thing with the x part. Okay? Woo!
Easy way now.
That'll make you sweat a little bit. Alright, so we got that, we got that.
Or you could just say, be the power rule.
Okay, I just want to throw some notation at you. Once you do find that derivative, it's going to be called f prime of x. F prime of x.
Little
If you find the
apostrophe.
second derivative, that would be f
Prime.
double prime, prime prime. Let's see what else we got.
Or dy over dx.
We have finished?
Oh, that is, we're done.
Wow. You guys know how to find a derivative.